Okay, 12.2 part 2. So we're going to start off with subtracting instead of adding. So when we're talking about combinations. So example 3, our school has 9 scheduled games, 9 scheduled soccer games. We want to attend at least 2 games. Okay, that's the important part there, at least 2 games. How many different combinations of games can you attend? Well, for each of the 9 games, so we have 1, 2, 3, 4, 5, 6, 7, 8, 9 games. For each of the games, we can either attend or not attend. So there are 2 possibilities for each one, attend or not attend, times attend or not attend, times attend or not attend, etc., etc., etc. So 9 times we could either attend or not attend. So that means that there is a total of 2 to the 9th different combinations of games that I can go to or not go to. If we attend at least 2 games, then that means that we can only not attend either 0 games, in other words, we go to all the games, or we can not attend 1 game, which means that we only miss 1 game. So the number of ways that we can attend at least 2 games is 2 to the 9th power, okay, minus how many different possible ways we can go to 0 games, and how many different possible ways we can only go to 1 game. Well, 2 to the 9th power is 512. So there are 512 ways I could either go or not go to all of the games. But I'm going to go to at least 2, so that means that I'll either not attend any, okay? So I will either miss no games at all, which means that there's only one way that I can miss no games, and that's by going to all of them. And I could only miss 1 game, which there's 9 different ways that I can miss 1 game because I can miss any of those games. So 512 minus the quantity of 1 plus 9, so 512 minus 10 is equal to 502 different ways that I could go to at least 2 games. Now, the binomial theorem allows us to expand any binomial, a plus b, to the nth power using the different number of combinations of each of the values of a to a power and b to a power. So what we do is we use those combinations as the coefficients on the front, and then we have our first term in descending order, so starting with the value of n out here and then going all the way to 0. And then our b term will have a coefficient of whatever r is, and r is going to start at 0 and then work its way up. Okay. So first we'll do example 4. So we're going to start by doing this for x plus 5 raised to the 3rd power. So for x plus 5 to the 3rd power, our first coefficient is 3c0, okay? X to the 3rd power, 5 to the 0 power, plus, then my next term is 3c1, x squared, 5 to the 1st power, plus, my next term is 3c2, x to the 1st power, 5 to the 2nd power, plus, and then finally my last term, 3c3, x to the 0 power, 5 to the 3rd power. So notice that my coefficients on x are descending from whatever we were originally raising the binomial to the power of, so they descend 3, 2, 1, 0. And my exponents on the b term, my 5, are in ascending order starting from 0. So 5 to the 0, 5 to the first, 5 squared, 5 cubed. Okay? And then my coefficients on each of those are the possible combinations in ascending order. So 3c0 is 1 times x to the third times, and then 5 to the 0 is 1, plus 3c1 is 3 times x squared times 5 to the first power is just 5, plus 3c2 is 3 again, times x to the first power is just x, times 5 squared, which is 25, plus 3c3 is 1 times x to the 0 is 1 times 5 to the third power is 125. So simplifying all of that, 1 times x cubed times 1 is x cubed, plus 3 times x squared times 5 is 15x squared, plus 3 times x times 25 is 75x, plus 1 times 1 times 125 is 125.